Let's see how to solve a word problem with two variables in position and time. The question here is, on an upstream trip, a canoe travels 40 kilometers in 5 hours. Downstream, it travels the same distance in half the time. What is the rate of canoe in still water and rate of the current? So the problem is like this. Let's say this is the water, and if the canoe is moving upstream, let's say from here to here, then it travels the given distance. Let's say the distance from here to here is 40 kilometers. So this 40 kilometers is covered in 5 hours when it goes upstream. But when it is coming downstream, then the same distance is covered in half the time. That means 2.5 hours. Now, why is it so? So it is so because the water current is downwards, right? So when the canoe is coming downwards, then its speed increases because of the water current. So let us say that speed of, we'll say let speed of canoe in still water be x and speed of water current be, let's say w. In that case, while the canoe is going upwards, so what is the speed? The net speed will be x minus w, correct? So net speed will be x minus w in this case. While it is coming down, the speed will be x plus w, because both will add up, right? Water is flowing downwards. So water, w, is acting downwards, right? So that is our water. So when the canoe is going downstream, the two speeds add up, and therefore it takes shorter time, right? So that is kind of an scenario which we can see, and the distance being traveled is 40 kilometers. Now we know our distance, speed, time triangle, correct? Now it says that distance is speed into time. Now here we can get two equations. One, while going upstream. So what happens when you go upstream? When we go upstream, then the distance is 40 kilometers. So let's make a table here. So we'll write distance is 40 kilometers, and what is the speed and what is the time? Let's relate all the things. For upstream, it is 40 kilometers and speed is x minus w and time is 5 hours, right? When you go downstream, then the distance of 40 kilometers is actually covered in half the time, which is 2.5 hours, since the speed is x plus w. So that is the kind of table which we get in this scenario, correct? Let me make a proper table here. Right? Now from this table, we can get our equation. That is, speed is distance into time. So we can get two equations from two scenarios, upstream and downstream. So we get 40 equals to speed into time, which is x minus w times 5. Now this can be simplified as 40 divided by 5 is 8. So 8 equals to x minus w. The other equation is 40 is equals to speed is x plus w times 2.5, Now we can divide 40 by 2.5 and we'll get double of 8, which is 16, equals to x plus 2. Correct? So we have two equations and two variables. Let's name these equations as 1 and 2. So I'm calling this equation as equation 1 and this as equation 2. Now if I add them, what do I get? So let me add equation 1 and equation 2. So if I add them, then I get 2x here, right? W and W becomes 0 and 8 plus 16 is 24. So we get 24 equals to 2x, or x is equals to 12, correct? But if we subtract them, that means if we do equation 2 minus 1, then what do we get? We get 16 minus 8 is 8, and w minus w will become 2w, and x minus x will be 0, so we get 2w. And from here we get w equals to 4, and that gives us the speed of canoe in still water and the water current, and therefore we can write down our answer as still water, canoe speed in still water is, which is x for us, we'll write x is equal to 12 kilometers per hour, and water current is 4 kilometers per hour. I hope you understand how we solve this question. Now first we try to make a figure so that we could understand the scenario. So that's a river and this is the distance of 40 kilometers. Let the speed of water or the water current be w, and let the rate at which canoe is traveling in still water be x. So when the canoe goes against water, its speed will be x minus w, water current, or when it is going downstream, then both get added up. Then we made a table of values for two different scenarios, one for upstream, one for downstream. Distance being same as 40 kilometers, speed as we worked out, x minus w for upstream and x plus w for downstream. And time taken was 5 hours for going upstream and half of 5, 2.5 for downstream. Now that gave us two equations. Speed is distance into time. So one for upstream, the other one for downstream. And then we eliminated one of the variables and found the other to get the answer, right? So that is how such problems should be solved. Thank you.